Good afternoon to everyone watching today. Welcome to this WindEurope Sofa Talk on advanced manufacturing in the European wind industry. My name is Josh Gartland. I work at WindEurope and I'll be moderating this discussion today. Advanced manufacturing of wind turbines will become increasingly important in the delivery of an energy transition that's made in Europe. Under this system, operational and information technologies come together to boost factory output and reduce costs. Automation, robotics, advanced sensing, and AI can enable breakthrough innovations in both products and manufacturing processes. This will be a key factor in Europe's continued technology leadership in wind energy. The European wind industry today is already undergoing major shifts. Turbines are getting bigger, development cycles are getting shorter, and there's more modular manufacturing. The questions we're going to try and answer today are: what impact will advanced manufacturing have? How can it support Europe's continued wind energy technology leadership? And what policies can help? So joining me today is a distinguished panel of guests to discuss all of these questions. I will introduce each one of them in turn. First, we have Ruada Rodriguez, who has been president of the European Technology Association ORGALIM since November 2019. Since 1st of May 2021, Ruada has been CEO of Signify Germany, a major lighting provider. And between 2009 and 2021, Ruada was a member of the board of Schneider Electric Germany, where she served as CEO between 2009 and 2016. Ruada is also vice president of ZWEI, the German Electrotechnical Association, and Ruada also holds an MSc in construction engineering. Thanks a lot for being with us today. I'm going to move on to Hanif. Hanif Mashal is Vice President of Engineering at LM Wind Power, the rotor blade manufacturer. He has more than 15 years experience and deep strategic expertise in technology, manufacturing, and the development of wind farms. His background includes both onshore and offshore within multinational US and European industrial companies. Hanif holds a Master of Science in Power Engineering from Aalborg University, Denmark, and a Master's Certificate in Sustainable Energy Planning and Management. Welcome, Hanif. Thanks a lot for joining us. Moving on to Stefania Ferrero. Stefania is Business Development, Marketing, and Digital Innovation Manager for Machining Systems at the Italian industrial automation and robotics firm Comau. Stefania joined Comau 2 years ago with the target of supporting business transformation and digital integration, specifically within the machining and PWT business. Stefania, you'll need to explain what PWT means, but also in connection to the other business segments. Stefania has experience in business development, marketing, and transformation, developed in companies active in diverse verticals in connection to product development and design thinking. Welcome, Stefania. And finally, we have Victor Pico from Aratex. Aratex is a Spain-based machining and automation company. Victor has worked at Aratex for 10 years in several roles and is currently responsible for business development for diversification. Before that, he worked for 3 years as general manager in China. Victor is a mechanical engineering graduate from the UPC ETS EIB University. Welcome, Victor. It's a pleasure to have all of you here. I think we have a really good range of expertise from the whole value chain. But I wanted to start with you, Ruada. You, as president of ORGALIM, have a great overview of what's happening in advanced manufacturing today. I was wondering if you could maybe define advanced manufacturing for the benefit of the audience.
Thank you, Joshua, and thank you for inviting me to speak in this event. So when we talk about advanced manufacturing, I think we need always to have two aspects in mind. One aspect is, of course, the technological aspect, which means using the data from sensors, from field devices, and then with the help of course, with the help of connectivity to transport this data, and then running the softwares will help improving the and optimizing the outcome, whatever the outcome is, if we talk about designing the product, optimizing that, or up to the finished goods. This is very important aspect. This is the basic aspect. But there is also another aspect, which is the business aspect, and the fact that through this complex integration on different levels and in different axes, we have the opportunity to develop completely new business models. And by developing these new business models, companies get much more resilient because the new business model will always help you to have first to have some revenue also when we are facing a crisis or facing downturns in the economic cycle. And these new business models raise from the fact that we can integrate with advanced manufacturing technologies the supplier through the manufacturing process to the customer. But we can also connect the product during the complete life cycle of the product. And by this, we can develop services like predictive maintenance and other services. So this business aspect is extremely important because it has the biggest gains when it comes to advanced manufacturing, both when it comes to resource efficiency, so everything linked to sustainability, but also in terms of creating new revenue streams for the company. So if I would summarize, it's difficult to define such a complex system, but it's really the new level of manufacturing. So it's really the opportunity when deploying that manufacturing process, advanced manufacturing technologies. You get the efficiency gains, you get the sustainability gains, and you enable a new business model, which drives competitiveness and drives innovation.
Thanks a lot. That's a very concise summary. So it's not just about technology, it's not just about improving efficiency on the factory floor, it's also about new business models. I was wondering if you could perhaps summarize some of the main policy developments at EU level to date. So perhaps some of the problems that we need to solve at EU level.
Yes. So when it comes to this very complex digital integration in different axes, as I said before, from design to finished product, from supplier to customer during the complete life cycle of the products, you can't do that if you don't have a standardized architecture. Now, the good thing is that this standardized architecture, which is at the base of what we call Industry 4.0 transformation, the good thing is that this is made in Europe. And why this is it was possible to make this in Europe is the fact that we have a very strong domain know-how. So we know the processes, we know the hardware. So we come from a very strong industrial base, and we still have a strong industrial base, which brings a lot of R&D investments and is driving the innovation. So that's the good thing. Now, where the challenges comes when it comes to the policy is that the European Commission launched a new industrial strategy last year in March. And that was a very ambitious and a very complex and a very, let's say, a detailed plan and ambition. What is a little bit challenging is the fact that it was very much influenced by the Corona crisis, so 2020, and it is very much around these industrial ecosystems as they are defined in the industrial strategy, which are not the manufacturing ecosystems I am talking about when you try to put together your supplier through the manufacturing to your customer to optimize that ecosystem. In let's say the ecosystems in this approach of the industrial strategy and the European Commission, these are sectorial ecosystems. And why I'm saying that this is important and why it was is linked to the corona, because on one side, with this sectorial view, what the Commission is trying to do is how to boost sectors which were very much impacted by the corona crisis, like, for instance, tourism or aviation. On the other hand, it tries to boost the decarbonization in sectors which are very difficult to decarbonize, like the energy intensive, so steel and cement. Also, it's the good thing, and now it's linked to the wind, is also where do we have really the drivers of the energy transition, and that is everything linked to renewables, so wind and solar. So this is a little bit, this is not a little bit, this is the approach in the industrial strategy. And what is missing here completely is the focus on the underlying enabling technologies, which actually make all this possible, the green and digital transformation of all the other sectors. So regardless if you are manufacturing a wind turbine, or you are manufacturing a car, or you are manufacturing a battery, if you don't make that manufacturing based on advanced manufacturing technologies, if you don't grasp the opportunities of efficiency, sustainability, and new business models, which the new technologies are giving, then this manufacturing will not be competitive, and the risk is very big that this manufacturing moves somewhere else in another region. So that is the big challenge which we have. Now, there are a lot of things which can be done, and I don't know if we should go now on this topic, or we want to take it later on.
I think, yeah, I think let's take the solutions later, but I think the problem, you've defined it very well. The problem is perhaps that the industrial strategy is looking too much at individual sectors and not taking a horizontal approach to look at what will enable Industry 4.0.
Exactly. The transformation of Industry 4.0. Exactly.
Yes, that's very clear. Thank you. I was wondering if I could maybe move to Hanif for an overview, a helicopter view of the big trends in wind turbine manufacturing today, and perhaps an example of where LM Wind Power is using advanced manufacturing techniques already.
Sure. Thank you, Joshua. I think maybe I take a step back and add to what Radha said. She mentioned about the business aspect of advanced manufacturing. And to take a helicopter view, looking just to the wind business or wind sector, it's definitely a strong growth sector, but it's also a very cyclical one when it comes to the demand and the volume. It's a growth because of the significant commitment from both private governments for energy transition, climate change. So that basically drives the push for it. But the volume is cyclical one because the new policies takes time to be fully implemented. You have construction, manufacturing, execution capacity in the market is not yet there. Then you have cost of goods sold, supply chain, localization, now with the COVID inflation fears. So that makes the demand part of it very cyclical. And from an LM point of view, for the growth part, strong growth, we see the growth in onshore anywhere between 3 to 4%. The size of the onshore turbine increases every 2 years. And if you look at the offshore one, every 5 years, somewhere around 10 to 12%, the size gets bigger. And by size, it's basically driven by the rotor. The rotor, the blades is what captures the energy. And that's kind of the first line of industrialization and manufacturing. So coming to LM, what do we do at LM to kind of balance the strong growth, but at the same time manage the cyclical volume change, be it for whatever reason? We look into two things. One, we need to make sure that we maintain the cost competitiveness of the product. Otherwise, the business will not make sense. And on the volume change, our focus would be around manufacturing. How do we reduce the material consumption? Some of the things, for example, at LM, what we do on advanced manufacturing, use of sensing technologies in our manufacturing. How do we lay up the material in the blade? How do we ensure the speed is consistent? There is a speed of flow in the factory. Another example is additive dip. So additive by itself, and I can talk later on a little bit more, it's not the classical additive technology that's used in aerospace or in healthcare, where in wind, we take some fundamentals of that additive fundamentals and then try to find a way to include it into the blade. To give you an example, additive by itself is you basically add material in order to create a part, versus the conventional subtractive manufacturing approach where you mold something and then you chip off to get the part you need. In high precision sectors, be it aviation or healthcare, the additive in a classical approach is very effective. You can make very precise parts out of additive. In our sector, we make big parts. So what we do is we focus on how the additive reduce the waste, the material waste that we create big parts like the blades. How the additive brings consistency and control of manufacturing processes. And last, how our investment in CapEx can be utilized across multiple products. We cannot have a business model where every product shall have its own CapEx. It's just not going to work. So the advanced manufacturing is going to help us to reduce the material consumption, have consistent process, reduce waste, that by itself is cost, but also sustainability, and then reutilize the investment in CapEx we have. So those are a few examples what we do at LM in order to balance growth and the cyclical nature of our sector when it comes to the volume demand.
Great, thanks a lot. That was very clear. So I maybe wanted to move to Victor and Stefania, who are both representing solutions providers in the advanced manufacturing space. So a question for both of you, maybe Stefania, you can start, is can you give an example of an advanced manufacturing solution that you've deployed in another sector?
Yeah, I think that as Comau, we have developed lots of advanced manufacturing solutions starting from automotive needs, because automotive still represent our core business, even if we have started to differentiate our core business towards many other verticals. And we found that what we initially developed for automotive in a serendipitous way can be, I don't say easily, but can be applied to other sectors and offer interesting solutions also for other sectors. I give you here 3 examples that are taken out from our business segments. So if I think about our electrification business segment, we have developed a solution that is connected to vision system, air and thermography, that is called Myra, and that was conceived initially to improve the battery inspection, battery module inspection, and that sees a lot of application also outside its original vertical of application. A second example is another solution that comes out of our automation system. It is called Comau Flex. We conceived that to permit to assemble up to 7 vehicles at the same time on the same line, and the solution completely size agnostic, size independent. And we see that this kind of solution sees application outside the automotive world, especially where you have to manage a high degree of complexity, of paths to be managed at the same time, and that are and it is also subjected to volume and part change. The last example then comes out of the business segment I belong to, that is machining and PWT, that is powertrain. We also, among other things that we do,
can you explain PWT?
Powertrain.
Oh,
yes, exactly. And yeah, because in this field, beside many other things that we are doing as machining, we also historically manage all the systems that are deemed to produce add-on blocks of the powertrain engines. And in this case, we manage a very complex system where time to market is very strict, and also you have to manage a certain complexity in the production. In this system, we are also used to manage the logistics of parts and tools with some aerial solution where we utilize complex gantry systems. And we are receiving a lot of requests of this kind of solution outside automotive, especially for renewable, in the renewable sector, and also in the wind sector. So I gave you 3 examples of solutions that we have identified initially within a very traditional, historically, sector like automotive, and that can see a lot of application outside it.
And maybe a quick follow-up question. What are the big differences you see between automotive and wind industry manufacturing?
Yeah, I see still some differences, but I would say that compared to some years ago, the differences are decreasing. So I would say from the easiest one, cycle time and dimensions, because of course that we have to recognize that the automatization level, that is our core business. So we automatize things when the volumes justify the fact that the operation are not done by humans, but have to be done by machine robots. And it is the moment where Comau enter in the game. I would say that still there are differences between the 2 sectors, even if I would say that wind industry now is changing a lot and is growing also in terms of automatization at a high pace. What we also observed is that some operations that are connected also to unsafe operation in automotive are 100% managed through automation, and in wind this is not done at the same level, because we see that some heavy material handling with cranes or surface treatment are done with dust, for instance, are done still with humans instead of robots. What we see some differences is also in the application of the techniques of design to manufacturing and design to assembly. This is something that is a must within automotive. We see some trends now within the wind industry, and what we see is that increasing this trend would be absolutely beneficial also for this industry in terms of automatization of certain solutions, and also to conceive some technical solutions that are really cost effective and cost driven. What we see is that, as I mentioned before, I mentioned this solution about thermography and visual inspection. So I think this is still a difference between automotive and wind, but we see an increasing interest into this kind of solutions. And where I think that there are still some point of contacts, it is in whatever is connected to dispensing, bonding, and also why not plant logistics. So I mentioned also before Comau Flex, and according to me, there are a lot of points in common in terms of logistics management.
Okay, I think that's really clear. I'm just going to pass to Victor to get his perspective on basically the same question. So if you could maybe give an example, Victor, of an example where you're using or you've deployed an advanced manufacturing solution for another sector. And yeah, perhaps as Stefania was saying, how is that sector similar or different to the wind industry?
Yeah, so, well, first of all, thank you to have the opportunity to be here. So Aritex has 60 years, this year is 60 years of experience in car industry and 25 years of aeronautics. So basically this is the two markets, and 2 years ago we start really hard working for the wind industry. So mainly I will say the robotics in general. So as Stefania said, for the car industry, automation, robotics are really key. So we are talking about cycle times that are really high. And to put one specific point, so it's drilling and riveting robotics that we developed by ourselves, some kind of equipment. I think that this is giving empowerment for the market for really big parts where you need high accuracy. You need this kind of solutions in order to achieve quality and speed at the same time this is the key for a good performance. And in terms of similarities, so I would say that wind industry is a combination of high level of automation, because as Hanif said, so in offshore that we currently are working in Halix program, and I think that offshore market is increasing a lot. So the level of automation that we need for the car industry, and also the combination of the high quality and high accuracy of the aeronautics. Okay, so finally aeronautics the requirements are really high, and in offshore, due to the fact that the turbine is placed on the sea, so the quality is really a key factor in order to reduce as much as possible the cost in service. That maintenance service for the offshore is really high. Currently, the blades are 100 meters length, 8 meters generator. We are talking about 7 millimeters air gap. So the high level of accuracy during all the assembly is really important. In order to achieve the good performance of the turbines. So currently, what we are doing is we are taking profit of all our past experience and all our expertise in automation, and we are applying some robot bolting applications, some automatic dimensional check for some parts, and applying as much as possible Industry 4.0 in order to give the traceability in the full process. Okay.
Perfect. No, thanks a lot. Maybe just to go back to you, Hanif, very quickly, it seems like one of the reasons that we haven't reached the same level of automation in the wind industry as in the car industry is there's not the same, we haven't yet reached sufficient market scale. And I guess you touched on this when you said that the wind industry is cyclical, it is very policy dependent. But I was wondering if you could maybe expand on that a bit more and maybe tell us what are the bottlenecks to reaching this market scale. Yeah, over to you.
Thank you, Joshua. Yes, I think other colleagues talked a lot about the automotive aerospace and some similarities, and Stephanie, you mentioned the size. some of the bottlenecks that we see when it comes to advanced manufacturing, number one is we have done some even some pilot trials of putting some more advanced robotics or systems. The number one is training of the labor in mastering the use of the new manufacturing technologies. If you look at historically in the wind, and I can speak for the blade, the skill level of manufacturing blades in a traditional way versus concepts that we are piloting right now is totally different. So the number one thing is, how do we train the labor? Right now, the training of the labor to use these technology, all that burden is taken by the companies, be it a company like us, LMG, Renewable, or some other companies in the sector. And this is where I think public institutions or EU in general could help retraining and having those educational programs for the workforce using these new advanced technologies in the production lines. So that's one. The second one is, of course, apart from the cyclical volume, the second one is around expectation of labor and job numbers in production lines. It goes without saying, and the car industry has seen it in the 70s, especially in Europe. You had the BMWs of the world and Mercedes. They start taking advanced manufacturing or the robotic arm from Japanese, and it happened in the 70s, and it will have an impact on the expectation of how much labor you are required to put in a production line. So that expectation from the governments, from the EU Commission, needs to be balanced. It doesn't mean that there will be no job creation, but there will be high-skilled job creation. And that's where we need to kind of look and fine-tune those expectations for the local content, job creation, and the government incentive. The third bottleneck I see is that we need to address is around, as we get these new technologies implemented, obviously they come with sensing technologies, be it a laser sensing, be it an image sensing, and there are some fine lines that we need to really work to clarify, specifically around general data protection right. There are technologies that can take picture of a production line or production processes, flags any quality deviations or any layup of the material, so early warnings to ensure we have the right quality out of the line. And all that needs to be addressed with the GDPR, which is the General Data Protection Rights. And how do we make sure that while we protect the workers' right, but also bring these advanced technologies? So in summary, three things I would say. Of course, it doesn't address the volume, volatility, or cyclical side, but just purely looking to Europe, training the labor with the new skills, adjusting expectation for the job creation. Actually, it should be more of a high-skilled jobs, and how do we protect the workers' right as we bring these advanced technologies into our factories, be it in the blade or gearbox or generator. So that's yeah, what I would say is the bottlenecks.
Yeah, that's really informative, and I think it brings us well onto the next question, which is for Rada. Specifically, how, in your perspective, can the EU, through its own policies, boost advanced manufacturing in Europe? Is it about more funding, so more funding for R&D, for training, or do we need a more holistic approach?
Well, Hanif gave me very good entrance point for this questions, and I totally agree with the challenges he was mentioning. In fact, I said before that okay, we had an industrial strategy based on those ecosystems last year, and this year, for some weeks ago, we had the update of that industrial strategy. And that's important to mention because in the update, it was mentioned that advanced manufacturing is a strength of Europe, and it was mentioned that this is important, but no action behind on how to boost it. And now I'm coming to what Hanif is saying. Today, when it comes to the really advanced in manufacturing industry 4.0 transformation, we have pilots everywhere. And how to scale up from the pilot phase to go to really real scale production, and to do that fast, taking in consideration that other regions are also doing the same and investing a lot of money. Now, you mentioned the skills, the training, the labor, that's all extremely valid, and the sensing and the technology. So let me take one aspect on the data. We are massively lobbying for the fact that industrial data has to be treated different from personal data. When we talk advanced manufacturing, when we talk artificial intelligence on the first level of machine communication, machine to machine, that let's say that type of communication is not the same as when you have a face recognition and doing a person profiling. So it has to be treated completely differently. And for us, it's extremely important that industrial data is not so that, let's put it like that, the GDPR or whatever other regulation we have for personal data is not one-to-one taken on industrial data, because that's not working in this way. So that is a very important one. Very important also when we talk about data sharing, because I talked about new business models. I'm thinking about wind, offshore, you know, coming to the digital twin, trying to make improvement or even services on a digital twin. So remote, that is a very interesting aspect and opportunity and technology. But for that, you need a lot of data sharing. Now, when it comes also to data sharing, again, to make the distinction and to make sure that this is based on contracts base, because you involve more companies, not one single company. And the data, the production data, is something which is extremely important for a company, as you know, as it's a manufacturing know-how. So by sharing that data with another company, maybe a service company or whatever other company, needs to be based on contracts. It cannot be somehow of mandatory data sharing between the companies or even other regulation. And then another aspect which I think is extremely important is, okay, the financing is important, because this is such a big transformation. This cannot be done with small investments. For a company which goes for a full-scale Industry 4.0 architecture, it's a massive investment in its money, and it is also know-how. So on the know-how, we have clearly a bottleneck. And then we have also another thing which we have to be very careful in regulating too much too soon. So especially on the new technology, artificial intelligence, machine learning, these are technologies which are just developing now. So trying now to put them in a very tight corset of regulation would be too fast and too soon. So this is also something which we need to take care of. And maybe the last thing, also very important, our industrial footprint in Europe is based on very many small, mid-sized companies. Not very, very small. I mean, these technology companies are pretty big, but still small, mid-sized companies. If you put too much administrative burden on these companies, they will not have the room for developing innovative technologies. So that's also an aspect which, let's say, needs to be taken care of. And in my opinion, what is the most important thing is to have the political focus on advanced manufacturing. And we don't see today that we have a political focus to really tackle all these topics and much more, which we are trying now to mention in this short time.
Thanks a lot. I mean, yeah, it seems like it's about not over-regulating, about providing the financial resources, and about taking a specific approach to data for industry, and not to, you know, to adopt a one-size-fits-all approach to data protection. Victor and Stefania, I was wondering if you could maybe look into the future a bit and talk to us about what trends you see emerging in advanced manufacturing. What are the next frontiers that you see from your perspective as solution providers? Maybe Stefania, can you start again?
Yeah, with pleasure. So in terms of trends, there are many things that we can see. What I can mention today is something that on which we have started working as a automation company, because before we both have named additive manufacturing and also precision machining. So what we are trying to do and what we have already started to do with some partner of us, especially in some innovation programs, is to merge machining, that is the area I belong to, with additive manufacturing, especially applied to the repair industry. And so we see that this may be quite interesting for the wind industry too, where instead of replacing entire part, it's very interesting to conduct the repair operations and also locally. And this is why also we are envisaging some hybrid solution where we mix up machining and additive at the same time with a very flexible machining operation done through robots, but also non-conventional CNC machines. So this is under our point of view what we are, what we see, and that is for us one of the key areas where we would like to play in the coming months.
Great. Victor, do you have a response to that question as well, in terms of the next frontiers for advanced manufacturing?
I think that, well, we have said several times, so additive manufacturing for us and Industry 4.0, so it's for us the trend, okay, the current trend that manufacturing is taking really care about that. In fact, Aritex is involved in Moldam, a European program that is IMASD program, okay, that is doing mold printing with big scales for the wind industry. Okay, so we are working with Tecnalia, and there will be mainly two end users. One will be Suslon and the other will be Ernova, where what we want is to increase the productivity and reduce as much as possible the lead time of the deliveries for the molds, in focusing the wind industry.
Okay, perfect. Very clear. I have a question from the audience for Hanif. So we've heard a lot about 3D printing over the past few years. LM Wind Power won a grant recently from the US Department of Energy to explore the manufacturing of 3D printed blades. So we don't want you to give too much away, but how exciting do you see this technology and its use for the future?
I would say it's a very exciting one, and we have been working on this technology for a while, and now we also have a grant. Basically, the way we see additive, I mean, the blade itself, it's a massive structure. If I take one of our blades that's on a wind turbine, Haliade-X, 12 megawatt, this blade is 107 meter, 51 tons of composite in one piece. So it's, first of all, it's not a blade that the robots can build it. So one of the first things we start to look when it comes to manufacturing of these large structures, how do we take in parts of the blade and start to use additive and 3D printing to manufacturing. And this is exactly what that program is. It's not for the full part of the blade, without going into more details, but we are really focusing on how do we manufacture using 3D the structure part of a section. And as we build it, and actually we have right now even full-scale systems built, and in this kind of technology, as we validate it, then that part could become bigger. So it's very valuable for, number one, consumption of material. We need to be sustainable. I mean, we can't just take a bite out of our planet for every wind farm we build. So we need to know how we can utilize sustainably these raw materials, be it glass, carbon, resin. So material consumption. Second, better quality control. And third, how the same machine setup could make multiple product with a minimum configuration change in a production flow. So that's what we are focusing on that program. It's for the blade, because we believe that having additive in a running product is going to bring value to it, rather than focusing on making our equipment out of additive. That's kind of job of our partners who can do it.
Okay, great. I had a question maybe for Rada. Do you see a role for standardization in helping the rollout of advanced manufacturing? So perhaps at a global level, a global agreement on industrial data sharing, or do you foresee the EU kind of going it alone and the US adopting maybe its own set of standards? How do you see that emerging?
There were several questions. So first of all, standardization is extremely important, because we are talking about interoperability, and we are talking about a complex, let's say, architecture, industrial architecture. Without a standardized way of interoperability, it will not be possible to bring together so many different stakeholders. So standardization extremely important. Second, standardization is changing also extremely in Europe, and it is changing all over the world. In Europe, we had a very, very successful way of standardizing the products, but it's true, it was mainly based on, let's say, traditional product standardization, not very much including so far what is happening on the software side, where there is more of open source approach, which is a completely different approach compared to the classical standardization. So standardization is changing. So we have to include also other way of doing standards, but nevertheless we need to come to a standardized view. Another aspect of Europe is where, yes, a little bit going in your third question, I think, is that it seems that we go a separate way. So up to now, Europe was very much influencing the global standards. So many of the IEC, of the EN European standards were IEC standards, and vice versa. So we are very much as companies involved in the global standardization as well in the European standardization. Now, what we see is that the European standardization was, over the last period of 2-3 years, really slowing down, and that is, of course, not a positive aspect. And here we risk that other regions are going faster and going. So the European, let's say, dominance of the global standards is decreasing. We are in very, very tight dialogue with the Commission, and I think that we get closer to each other, and we will find a way of speeding up also the European standardization. What has to be speed up is the process of harmonizing the standards, because in Europe, you know, the standards which is developed needs to be taken in all the 27 countries. So that's why we need harmonized standards, otherwise we can't apply them in all the countries. And this process needs to get better and improve from all parts. So from the industry part, we need to change our mind in when it comes to how to speed up the process. Also from the Commission side, because they are actually citing our standards to become harmonized standards. So very important the question. We need to improve it. We need to include the software part, and how to deal with the open source standards, and we need to make it faster.
Great, many thanks. Maybe one final question for Victor and Stefania. Again, it's about data. Do you think that the advanced manufacturing solutions for wind energy could be improved by using digital operational data of wind turbines? And do you see synergies between wind turbine OEMs, so the wind turbine manufacturers, and the wind farm developers and operators? Stefania, I don't know, do you want to take that?
Yeah, I will take that. So first of all, about the availability of operational data. So yes, for sure, this is interesting. And as we have already said, this is connected to the application of digital technology and collection of digital data. And we see that as the analysis of possible root causes that permit, for instance, to link the operational data of a drivetrain to its manufacturing process. This is a very interesting approach, possible interesting approach to find new ways to reduce, for instance, the wind generation downtime and avoid the error reiteration, both in manufacturing and in design. Of course, this is possible because we see that possible thanks to the application of available technologies already nowadays, both in terms of machine learning, artificial intelligence, and so on. Not easy, but it's something that has to be done and as a value for the final clients. And then to reply to the second question you raised, Joshua, about the fact of cooperating with all the key players and all the stakeholders in the value chain. Absolutely, this is fundamental. From our side, we see that having all this data available permit us as players from the manufacturing and automation side really to have a comprehensive and holistic approach to the clients. So not only concentrating in the pure automation, but also I would say approaching them under a design thinking point of view. So considering what are the user in every aspect of the value chain. So taking in consideration who has to build up the system, and also who has to dismantle them. So what we see is a rising request from many clients of us in taking in consideration not only the moment of automatizing a system in connection to a production, but also considering in a holistic way all the different aspects of the value chain. Okay, so, and this is possible because we have more data available, but it's also a challenge for a company like us because we really have to extend our know-how really further to the simple manufacturing process.
Mm-hmm. Victor, do you agree with that assessment that the more data that we have, the better the services that
absolutely
companies like yours can provide?
Yes, so what we are trying is to sensorize and promoting this kind of automation in order to record as much as data as possible during the complete manufacturing process. Data is really important, but also we are generating a lot of data, and what is important is to select the one that is giving an added value for the complete chain. No, so especially we are focusing in the critical to safety. So where exists a risk for the operator, where there is some kind of ergonomy problems that they are manipulating something, working in a height. So, and also where the critical to quality is really important, like positioning of elements, torque control in the bolting, that also is important to be recorded and to have this kind of traceability. Tolerance assembly in order, as I said, so to control these kind of gaps that we are talking that are really millimeters. And all of this well is guided through the Industry 4.0 and is doing all the data recording for the quality assurance and the continuous improvement. So I think that all this information is important for the manufacturer, for the OEM, and also for the rest.
Many thanks. I'm going to try and summarize the discussion. I think it's been really interesting. So I mean, we've gone through you know, what advanced manufacturing is, how it's not just about technology but also about helping to develop new business models. We've looked at how the cyclical nature of the wind industry and how perhaps the lack of availability of skills are maybe hampering the uptake of these advanced manufacturing techniques. We've heard also a bit about the differences and similarities between wind and other technologies, and also about what the EU can do. So we need, I guess the first thing is we need more political attention. For advanced manufacturing, we need a recognition at political level that it is an enabling factor to the competitiveness of Europe. And we also need a kind of pragmatic and, in some cases, light touch approach to regulation. I'm going to thank you all now, Rada, Hanif, Stefania, and Victor. I think it was a great discussion, and it's great that that you've joined us today. I just have one more announcement, which is an upcoming Sofa Talk. So another webinar from WindEurope, which is taking place on the 23rd of June, and which is all about how Europe can meet its wind energy goals. So there we're going to cover topics like permitting challenges, how to ensure the right level of port and grid investments, repowering, and also how to develop the next generation of wind turbines. So we will be with the Belgian Energy Minister, Tina van der Straten, WindEurope CEO, Giles Dixon, and industry experts from ZF Wind Power, Energy, and Vestas. So this isn't the last Sofa Talk before the summer. We hope to see you there. And again, thanks a lot to all of you for taking part, and also to the participants for watching.
Thank you.
Thank you
for
to you.
inviting me.
Thank
Thank
you.
you.
Many thanks.
Bye. See you.
Bye. Bye.